So another thing that we need is wall socket, places to plug things in. And there's two different calculations, and you have to take the bigger of those two. One is based on the area and the watts per square feet. And that'll tell you the number of receptacles that you need to make that much power available to that area. There's also one based on feet of wall space. And so that one gets you a number of receptacles too. And so you have to take the bigger of those two. So let's see how we do this. First of all, we have to know how big the area is. So let me look at, say, zone 1, and I'm going to look here. I've clicked on zone 1, and I see that when zone 1 comes up, it tells me under dimensions, the area is 11,101.86. I'm going to call that 11,100. So I've got 1,100, not 11,000, 1,100. And it is a lobby. So now I have to go figure that out. So there's a few ways to do that. I'm going to show you where I got these numbers from. Once you've got a zone picked out, you can tell from down here under the, it's down here somewhere. Here it is, the space type. If I click on that, I can actually say it is a lobby. And I just did that wrong. Lobby, there it is, lobby. Okay, and it tells me all sorts of stuff, and there's the power density right there. So I can say it's a lobby, and I can know stuff about that. Now, I've taken those numbers for you. Here it is, Revit lobby power density. Lobby, power density, that's your plugs. That's your plugs, 0.54 watts per square foot. So 0.54 watts for every square feet. The number of watts equals square feet times watts per square feet, 594. So how many receptacles do I need? Each receptacle is 180 watts, about. Okay, so I'm going to say it equals 594 divided by 180. I need 3.3 for that whole area. So that's one way of calculating. Another way is to look at my wall space. How many feet of wall do I have? Well, I'm going to have to do a little bit of looking around and dimensioning here. So I'm going to, because I need that distance. I'll get it. Need to zoom in so I can see what I'm clicking on. So there's wall. There's 40 feet that way. 40 feet that way. So 40 plus 40 plus 40 plus 40. But now I also have to check this wall and this wall. Okay, so and those are inside and outside. They're about 15 feet and 20 feet. No, 15 and, yeah, 15 and 20. So I have 40 plus 40 plus 40 plus 40. I think that's 160 plus 15 on the inside, 15 on the outside, 30 plus 20 plus 20. Let me go put that in there. Equals 40 plus 40 plus 40 plus 40 plus 15 plus 15 plus 20 plus 20. I love Excel, 230 feet. Now, here's the thing. You're really supposed to, have no more than 12 feet between each receptacle. The standard maximum length of a power cord on a light fixture or any kind of piece of equipment is supposed to be 6 feet. So 6 feet would get you to the middle of the space between two 12-foot apart receptacles. So 12 feet apart. Okay. So I should have equals this divided by 12. Says I should have 19 receptacles instead of 3 if I do it by feet of wall. Okay, and you're going to find that normally your feet of wall is going to be more important. And so max number of receptacles, I hate to put in 19. I'm going to put in 20. Okay, and that's what you're going to do for each zone to get your wall sockets. Okay, now in zone 2, you're going to have to go space by space by space, remember. Zone 2 is going to be your tough one because you have to get this wall space for the number of sockets in there, this wall space for in there, and there, and there, and there, and there, and there, and there. And then you need some along your hallways. Okay, so there you go. That's your calculation for wall sockets.